Hey, it's Mr. Nelson again, explaining to you how to balance chemical equations. This time we're still on practice sheet number 4, but we're doing problem number 4. Only one more after this for this section, so hopefully you don't need to see me and you just get it done. We'll see how this one goes. Okay, so the question is, or the equation is, when crystalline C6H12O6, which that is glucose, is burned in oxygen, carbon dioxide and water vapor are formed. Okay, first thing I'm going to do is I'm going to go ahead and fix these. C6H12O6. We know that that's glucose. So now here's the tricky one, because it says it's burned in oxygen. So oxygen has to be a part of the equation. We know that carbon dioxide and water vapor is going to be formed. So we're going to go ahead and start this off. Now this right here, I could say glucose. It is all nonmetals, but we don't have a name for it as far as how we're going to call it. So we're not going to worry about it. We know that it is glucose as its name. So C6H12O6. And one of the things I'm going to do is I'm going to just copy this, because then I don't have to do all the other stuff to it. So we're going to copy, and we're going to place it right down here. Okay, and we're going to go up and over. We're going to add to this, or it's burned in the presence of oxygen. So we're going to put oxygen. Okay, so we have our oxygen. Now it's going to yield carbon dioxide. Now I did not give you that, but carbon dioxide, the formula for that is CO2. I think you probably knew that one already. So we're going to go ahead and put CO2 here, and water. And the formula for water is, you got it, H2O. So H2, oops, and there's got to be a capital O. So there is our skeleton equation. But hold it, we got to also look at, is there any element by itself? Yes, we have one right there, and that is oxygen. So the question that we have to ask is oxygen diatomic? Hopefully you caught this before this point by now. So let's go ahead and look and see if oxygen is diatomic. We're going to look at our periodic table. Now again, you may have this marked down a little bit in your periodic table, but diatomic elements make a 7 on your periodic table. There are 7 diatomic elements, but they're not all in the 7. So there's nitrogen, oxygen, fluorine, chlorine, bromine, iodine. There's our 7 plus hydrogen. So is oxygen one of them? Yes, oxygen is. So we have to go ahead and make that diatomic. So now we have our chemical equation, our skeleton equation. We have to do what with it? We have to balance it. So we're going to figure out what is the molar ratio. So we're going to go back over to right here. So we're going to tab over, and we're going to put our elements. We have carbon, hydrogen, and oxygen. Now, one of the tricky thing is I have oxygen here and there, and here and there. So I have to add them all up together. So let's go ahead and put down what we have of each one. I have 6 carbons on this side, so we have 6. On this side, I have 1 carbon. On this side, I have 12 hydrogens. On this side, I only have 2 hydrogens. On this side, I have 6, 7, 8 oxygens. On this side, I have 3. So what do we want to start off with? Well, I always like to keep anything that's in 2 places, at least on one side, to the end, and maybe it can work itself out. So we're going to go ahead and we're going to start off with our carbon. Okay, So I have 6 carbon on this side right here. I need to have 6 on this side. The only thing that I can change is the coefficient, which is at the beginning. So we're going to put a 6 right there. Now we have 6 carbons, but it affected the oxygens. So I have 6 times 2, which is 12, plus this one over here is 13. So now we change to 13. I'm not going to chase the oxygen because I said we're going to wait and do the oxygen at the end and see at the end if we can go ahead and maybe it'll all work itself out. A lot of times it does. So we're going to go to the hydrogen. I have 12 hydrogen here. I need to have 12 over here. So I'm going to put another 6 right there. Boom. So 6 times 2 is 12. I don't have hydrogen in any other spot, so we're going to go ahead and put our 12 right there. So now that's equal. But notice it did change our oxygen. So now I have 6 oxygen over here plus the 12 over there. So 12, 13, 14, 15, 16, 17, 18. So this number changes to 18, which is nice because it's even. And this side can only be even. Let's take away the 6 that we have. Then I would have 12 left over, right? So if I took the 18, subtract 6, I would have 12. So I need 12 oxygens right here. So if I put a 6 right there, boom, now I would have 12 here plus the 6, and I would have 18. So I can put 18 right there. And so I have 18 oxygen on each side. I have 12 hydrogen on each side. I have 6 carbons on each side. I should be balanced. Let's double check up here. So there's 6 carbons. There's 6 carbons. There's 12 hydrogens. Here's 12 hydrogens. Now on this side, we have to, for oxygen, we have to do it. We have 6 plus our 12 is 18. And we have our 12 here plus our 6 there equals 18. So we're good. So our molar ratio is 1 to 6 to 6 to 6. So it's going to be 1 to 6 to 6 to 6. Go ahead and highlight it, look at it. Can I reduce? I have the 1, so I can't reduce. So we make it bold, highlight it in a new color. There we go. There's our answer. We know what it is. That's our molar ratio, or our digit number, sometimes I will call it. And we have a balanced chemical equation. There we go. Good luck on your last one. Hopefully this helped you out. As always, go Mohawks. Nelson out.